Students. Now in today's class, we'll discuss about what are vibrations and what are the fundamental things we learn from vibrations. Okay. So basically, vibrating, that means moving. So in your first year, either intermediate or first year engineering, you might have had one experimentation, velocity of sound in water table, like that. So there you have taken some tuning fork with some numbers, 230, 240, some 400, 440. Like this, some tuning forks you have taken and you hit it, and again some sound is coming. Water at some one-third height, two-third height. Like this, you are getting some sounds, bigger sounds. There you are finding the length of the water column. So some experimentation happened, right? Uh, how many of you heard about this experimentation? Tuning fork and water velocity. A resonance experiment will be there. How many of you had? I think my voice is coming.
Audible, sir.
Yeah. Just 1 minute. ప్రాక్టర్ ఉంటారు కదా, ఎవరు ప్రాక్టర్ తెలీదా? అదేంటి ప్రాక్టర్ తెలీదా? మీరు తెలుసమ్మా, మీరు ప్రాక్టర్ ఉంటారు కదా, మీరు ప్రాక్టర్ సైన్ పెట్టించు, పోనీ మీరు క్లాస్ చేస్తే పెట్టించు. ఓకే, రైట్. So these vibrations, I think there you have seen the tuning fork, right? So there you are having some key number, 200 Hz, 300 Hz, 440 Hz, like this. So that is a frequency. So at that time, you might have asked that faculty, what is this Hz? So faculty will reply, it is the frequency. Then if you are curious, again another question from the student could be, what is meant by frequency? Then the faculty will answer, the number of times this body will oscillate in 1 unit of time. In general, it is 1 second, right? For 1 second, how many times it is oscillating like this? Okay. So there you are having a small introduction about the vibrations without knowing this is called vibration, right? Okay. And again, vibratory motion. So vibratory motion means simply it is oscillating motion from a main position to the left and right, or up and bottom, or up and down, right? So vibratory means simply it is an oscillatory motion or simple harmonic motion, right? And equilibrium position. Equilibrium position means mean position. So there you are having extreme position and mean position. Just you remember, in an exhibition, we are having Mary Columbus. Just it is moving left and right. Just like there will be some boat-like structure. So there so many people could sit and enjoy. And by the motor, this is moving left and right to the extreme left side and extreme right side. The main position means at the middle position, right? Just remember how you experienced that moment. That is the best example for your vibratory motion or simple harmonic motion, extreme position, equilibrium position, all these things. Just remember that word. Or otherwise, you remember the very small thing, that is simple pendulum. Simple pendulum in a clock, it is oscillating to the left and right, and the bob or the pendulum, that is at the middle position or main position or equilibrium position or a straight line position. All are called same, right? So that movement is the simple harmonic motion or vibratory motion. We will give an example. Now, what will happen to the energy part, right? So after getting some initial movement, initially your pendulum will be in general, okay? Initially it will be at rest. Initially it will be at rest. Even your Mary Columbus also initially it will be at rest. By giving some energy, it is taking some time, maybe some 1 minute or 2 minutes or something, depends on the weight. So it is oscillating from the main position to the left extreme and the right extreme, right? Now, in the two extreme conditions, we are having energy differentials. In the main position, we are having high kinetic energy, and in the left extreme position and the right extreme position, we are having high potential energy, or you can call it as 100% potential energy at the extremes. While I am moving like this at this area and at this area, I am having only potential energy. Now I am moving downwards. That means coming to the main position, my full potential energy is converted into full kinetic energy. So at the main position, I am having 100% kinetic energy. And again, it will go to the left extreme, right extreme. As the energy is continuing, your movement of the potential energy to the kinetic energy and again kinetic energy to the potential energy. It is still continuing as a cycle till your input of the energy is halted, right? Now, the key terms. So there will be some nomenclature or the keywords, right? So in the concept of the vibrations, we are having some keywords. One is the time period or period of vibration. Period of vibration at the time period means so to move from one position to again the same position, how much time it will be? That means from left extreme to the equilibrium position, right extreme, again equilibrium position, next left extreme position. So the path from left extreme to again left extreme, or you can take anything, equilibrium to equilibrium, right extreme to again right extreme, right? So what is the time? It is called the period of vibration. And period of vibration, we call it as again time period. It will be in seconds. And next one is cycle. Cycle means, you know very well, the cycle means it is repetition, right? Repetition of the same thing. Just like you have the auto cycle, diesel cycle like this. Cycle means simply the process is in repetition. That means in a particular time period, got the point? In a particular time period. So, how many movements are completed during one time period? It may be 1 second. In general, the time unit is minimum 1 second. So, cycle means the motion completed during one time period. That means, uh, again, one thing you remember from the left extreme to the right extreme and again left extreme, it may take some time. Suppose it is 2.5 seconds, let it be. Okay. Now, what is meant by cycle? The motion completed during one time period. That means 1 second. It doesn't mean that x to x, y to y. That is called time period. So the time period may be some 3 seconds or 5 seconds. So cycle means simply in 1 second, how many movements completed. And next thing, the frequency. Frequency means number of times. That means how many number of cycles you completed in 1 second. So 200 heads. That means 200 cycles completed, right? Now you can ask one question. While movement of the tuning fork, I couldn't see with my eye. Okay, you cannot see with the eye because there will be visualization of the eye is limited, right? You can do some experimentation of the vibrations at your home. Take one blade or some knife. Okay. So at the end of the table, you press it and simply take a moment. That means the blade acting as a cantilever, you fix at one end or press it one end and give some small movement like this, right? You pluck it like this and you give a vibration like this, right? Or otherwise from top or bottom, whatever it might be, okay? Then it is giving some sound. It is giving some sound, right? Okay. So that's called vibration. So how many times it moved? If you are able to see with your naked eye, right? That means vibrations are less. It is in the visible range. Got the point? Suppose you are unable to see, you are thinking that the tuning fork still it is in static condition, but some sound is coming. Remember one thing: without vibration, sound will not come. Without vibration, sound will not come at all. Right? Is it okay? Now, the types of vibratory motion, there are three varieties. One is the free or natural vibrations, and second will be the forced vibrations. Okay, and third one will be damped vibrations. Okay, so there are out of the three, free and natural vibrations. And here you need to remember one thing: every rigid body, every rigid body will be in the state of rest according to Newton's first law. Right? Suppose you are applying some force, it is getting some moment, and the force applied will be equal to the mass and acceleration according to second law. Right? Now, where these two will be applied in the vibrations, initially the body will be at rest, then you give a small movement like this. You give a small movement, right? So due to this movement, if the body is undergoing some oscillation or a simple harmonic motion and it is following a particular pattern, so moving to the left and right, or east and west, top and down, like this, right? So oscillating with respect to a main position, that's called a simple harmonic motion. Now, what is this free or natural vibration means? Unless otherwise you are having some external force that is preventing it to move, the vibrations will continue ever long. Once you take a moment, right? Without any friction, without any air friction, without any link friction, the simple pendulum will continue to oscillate, continue, right? That's called natural frequency. That means when a body is undergoing some vibration without having any external agency to restrict it, how many times it is moving. This is an example for your natural vibrations, right? And forced vibration. Forced vibration means intentionally you are giving some extra force to vibrate according to your need. It has to move with 400 Hz. Okay, give some energy, right? Give that energy. It has to move with 1,000 Hz. Give more energy, right? But the forced vibrations you are having one difficulty, that is resonance. Resonance means very simply it is the reaction. Just like you are having action equal to reaction, resonance. Suppose I am having one rigid body, right? That rigid body is having some natural frequency. Okay. Rigid body means you can take anyone. Okay, let it be some rigid body is there, right? So it is having some natural frequency. That means suppose I am holding like this and moving like this, so it is moving in a way. After some time, it will stop. If it doesn't stop, that means no air resistance is there, no link friction is there, so it is continuously moving. right? So simple pendulum is continuously moving. But let us remove the part and take the simple pendulum out. Bucket is same, right? Now I am giving, so you note it down. What is the natural frequency of that particular simple pendulum? You suppose it is 250 Hz. Let it be, right? Keep it aside. Now start giving the energy for force vibrations. Give the energy to simple pendulum to move it, right? Now 100 Hz, okay, continue. 150 Hz, okay, no problem. 175 Hz, no problem. 198 Hz, again no problem. Now come to the natural frequency 200 Hz, right? Automatically, whatever the external vibration it is giving, the same thing is response from your rigid body as a natural frequency. That means high amount of response will come at your natural frequency. At the point. Then it is vibrating to the maximum extent, right? Whenever it is vibrating at the maximum extent, automatically, uh, just 1 minute, HOD is self-calling. Class చెప్తున్నాను వీళ్ళకి. I think everybody is able to see this PPT. Next, the third one will be damped vibrations. These are the natural, in general, we are having damped vibrations. Damping means simply continuously decreasing, right? Continuously decreasing means, suppose with all friction and the link joint friction or your air friction, everything is continued, right? You take your Mary Columbus, right? మనకి బాగా అలవాటైంది అది కదా. So you take the Mary Columbus. Once you stop the electrical energy, right? Suppose there will be some ticket of 100 rupees. So 5 moments or 6 moments he will calculate. After 6th moment, he will stop the motor. But still it is oscillating, right? Suppose he is waiting for some time, right? So initially it is going to the left peak and the right peak. Then slowly it is oscillating like this, and at the equilibrium position it is oscillating many times. Then finally, after some time, maybe 5 minutes or 6 minutes, finally it is coming to rest, right? But it is oscillating about your main position. Either oscillation amplitude may be small or big, whatever it might be. So at the bigger amplitude to the slowly to the very small amplitude. That is called the damped vibrations. Got the point? So reduction of the amplitude over every cycle. Because once I am moving left to right and again left, one cycle is completed. Next one, some air is restricting you, some friction is restricting you. So you cannot go to the right extreme 100%. So 90% of the right extreme. అంత హైట్కి వెళ్ళాం, కొద్దిగా వెళ్ళి మళ్ళీ అనుకొచ్చేస్తాం. Again, you are not reaching the left extreme to the 100%, right? So like this, you are coming very close to the equilibrium position and you are moving many times, right? So these are called different varieties. Now, the types of free vibrations are natural vibrations. Okay. This is actually the diagram given in the textbook, but you can consider not only shaft, you can consider a spring mass system, right? You can consider a spring mass system. Okay, then we'll do one thing. minute. I'll take the paint 3D and I will share with you. My bad network quality. Okay. Okay, now you can see this. So here I'm writing. I think you are able to see my handwriting here. Free vibrations, I'm having longitudinal vibrations and transverse vibrations, and next torsional vibration, right? So the longitudinal vibration means, suppose I'm having a spring like this, okay, a small spring like this, and a mass m is attached to it, okay. Now the longitudinal vibration means the body is moving along its axis or parallel to the axis. That means the body is moving like this. Then it is called longitudinal. Suppose it is moving left and right. Suppose this is the body M, and now it is moving to the left extreme like this, right extreme like this. So it is moving like this. So this is the axis perpendicular to the longitudinal axis. So this is called transverse. Then what is torsional? Torsional means twisting. So this is the spring mass system. Now this spring mass system is undergone some rotation like this. So let it be some omega. Just it is a twisting moment, right? So due to the twisting, this body or the disc or mass, whatever it might be, right? So sometimes you are having shaft and disc, or sometimes spring and mass is attached. So like this, different parameters, different applications will be there. Torsion means where you are applying some twisting moment. The total particles of the body will move in an angle, right? That is torsional vibration. Once you give the twisting moment and release it. Again in the longitudinal also, you give a, simply pull it downwards and leave it. Then it is oscillating up and down. It is called longitudinal, right? Just like your Mary Columbus or your normal things, pendulum type, this is transverse vibrations. Okay. So this is regarding your, what is meant by longitudinal, transverse, or your torsional vibration. Now in this class we'll learn about most of the important item is longitudinal vibrations and torsional vibration. Okay. Okay. The time is not there. We'll stop at very few things. Okay. One minute. Are you able to see the paint 3D clearly?
Yes, sir.
Yes, sir. Okay. Okay. Then okay. Now there are some important parameters. If time is there, we could have the full part of it. Okay. So let us now take natural frequency of the longitudinal vibrations. How to find? Oh, select the pen. Natural frequency of longitudinal vibrations, right? So longitudinal means very simply, so there is a, so this hatching means top ceiling is there. Now I am having a spring and a mass is attached, right? So this is in the static position, in the initial position, right? In the initial position. So this is having some weight, W is acting downwards, right? So once you are attaching this spring to the ceiling at the top, I am showing a red point, or otherwise I will show a green point. At the green point, you are having some attachment. Now simply you remove your hand. Then what will happen? Due to the weight W that is pulling downwards, the spring will move to some distance. At the point. Now what will happen? This is W. So what is the distance moved? Some delta. Okay. This is moving some distance delta. Now what is the relation between this W and the delta? There is S is called stiffness of the spring in Newton per meter. Now W this is the force downwards, or you can call it as weight. Okay, and delta is the displacement due to self weight W, right? Now, how you are calculating the stiffness? Stiffness is Newton per meter. That means your W by delta. So your W is equal to S into delta. This is the fundamental equation, right? Up to this, you don't have any vibration. When the body will vibrate, you give some moment. You give some moment. I will give some practical example for all of you. Just to take uh, the strings of Veena. Until unless you are plucking it, you will not get any sound, you will not get any vibration, right? Okay. Now you pull downwards, right? You pull downwards and give some moment. So it is moving to a distance x. Now it is oscillating. Now you leave it. After giving moment, it is oscillating up and down like this, right? Now, what are the different forces acting on this body? W is acting downwards, and at the top, S into delta plus X, right? Now, in the first method, generally we are calling energy method, and then not energy method, energy method is second. We'll discuss about KE and PE, kinetic energy and potential energy later. Initially, you can go for EG1, that is equilibrium method, right? So just to make a force equilibrium, W and S into delta plus X, right? So what is the restorative force or the restoring force? Once the body is applied some downward moment, what is the restoring force to bring it to the equilibrium position again? So this is W minus delta into S into delta plus X. So you replace W is equal to S into delta minus S into delta minus S into X. You cancel it. Now the restoring force will be equal to minus S into X. Okay. Now, according to the D'Alembert's principle, which you learnt already, this restoring force is causing the body to move it. So, what is that moment? F minus ma is equal to 0, not 0. The force is F minus ma, right? So, what is the restoring force? Minus S into X. This will be equal to, okay, you can cancel this, no problem. So, this restoring force is equal to what is the body moment? So, it is moving downwards, m into acceleration. This is m into acceleration, right? Okay. This acceleration you can quote in terms of x. When x is the displacement, dx by dt is velocity, d square x by dt square will become acceleration. So, my equation will become m into d square x by dt square, right? Now you can cancel this. I think all this will be recorded, no problem at all. So, this m into oh, select the pen. Okay, m into d square x by dt square plus s into x is equal to 0. Now you can go for d square x by dt square plus s by m into x is equal to 0. This is the fundamental equation of the natural vibrations. Now this is similar to the fundamental equation of the vibrations of a simple harmonic motion d square x by dt square plus omega square x is equal to 0. So, get analogy between these two, this equation and this equation which we derived. So, omega square is equal to s by m. That implies omega is equal to root s by m. Now, according to your fundamental equation, W is equal to S into delta. Got the point? So, M into G is equal to S into delta. From this, I can calculate S by M is equal to G by delta. So, omega is equal to root S by M. The same thing, root G by delta. Now, you can calculate the time period is equal to 2 pi by omega. So, I can write 2 pi into root delta by G. Right? Now, immediately the frequency will be reverse, omega by 2 pi. So, this will become, now we can write the frequency as 1 by 2 pi root G by delta. Okay. For your benefit, what I will do, I will increase the canvas. Okay. So, the frequency will be, yeah, 1 by 2 pi root G by delta. So, you substitute G is equal to 9.81. So, root 9.81 by 2 pi root delta. Finally, it will come to, I think, okay, we'll type it. Okay. Yeah, it came to 0.4985 by root delta. Somebody open the mic. Mute all. Okay. Right. So this is frequency is equal to 0.4985 by root delta. Right. Okay. Now in the longitudinal vibration, whatever you have, it is simply finding delta value, right? Because the frequency is a single parameter about delta. So how much moment, displacement moment you are creating in the body, that is the indication for your frequency. So delta. So now in mechanics of solids, the longitudinal vibration, that means the body is moving left and right, or in a simple harmonic motion, top to bottom, right? So when a body is having some tension, compression like that particular scenario, there you are having some tensile stress, compression stress that is creating in the rigid body, right? So there, how you calculated your delta? Delta will be equal to W by WL by AE, right? I think you know very well how this item is coming. Young's modulus is equal to stress by strain. Stress is equal to W by A. Strain is equal to delta L by L, right? That means finally delta L means delta, okay? Delta by L. So W by A delta L is equal to E. Now I need delta. So this will be WL by A into E. So W is the body weight, L is the length of the rigid body, A is area of cross section, E is Young's modulus. Now you find the delta, thereby immediately you got how much frequency the body is moving and what is the time period, you are able to find very easily. This is a very simple one, right? And remaining, okay, there are another two methods are there for getting this d square x by dt square plus omega square x or s by m into x is equal to 0. There are two methods, right? One is the equilibrium method, another is energy method, next one is Rayleigh's method, right? Okay, as far as your exam is concerned, okay, I will tell you the energy method also. Okay, so energy method, as we discussed earlier, the total kinetic energy plus potential energy at any point means either left extreme or the right extreme or in the middle, anywhere, the total energy is equal to 0, right? That means kinetic energy plus potential energy, total things are equal to 0. Okay, I think you are able to see this paint 3D clearly, right? Okay, now I will write the energy method. So d by dt of kinetic energy plus potential energy is equal to 0. Why I am taking the d by dt means the energy with respect to the time, it should be invariant. Okay. Now you can take an example of this body that is moving from left to right like this, right? So this is the left extreme, this is the right extreme. The body is moving like this. This is the main position. These are the extremes. It is moving like this. Okay. Now the kinetic energy that will be available in the middle. Potential energy will be available in the extremes, right? Now the kinetic energy, you call it as, in general, what is the equation? Half mv square, right? So half into m into dx by dt whole square. Agreed? This is kinetic energy. Now what is the potential energy? This is for the just an example I am saying. So this one you can remove it. Here we are taking example as the pendulum spring mass system. So this is the m and this is the new thing. This is x. Okay. Now the potential energy, initial moment plus s into x by 2 into x. Okay. So what is this S into X? It is the force, right? So this is average force, or you can call mean force into displacement. So this will be half S x square. Okay. Whenever you are having the kinetic energy plus potential energy is equal to 0, half S x square plus half m dx by dt whole square is equal to 0, right? Now, okay, and this is ke plus pe. Now I am making d by dt. So half s x square into, okay. So this will become 2x dx bit. Oh, 1 minute. I will erase it. I will write again. Half s 2x dx by dt plus half m 2 dx by dt d square x by dt square is equal to 0. So cancel the dx by dt, 2, 2, 2, 2. Then I am having left with, here s is left, x is left, m is left, d square x by dt square is left. So finally I am left with uh, okay, s, okay, m d square x by dt square plus s into x is equal to 0. Same equation which we got earlier. D square x by dt square plus s by m into x is equal to 0. Right? So this is what finally, either by energy method or the equilibrium method, I am getting an equation, a differential equation, d square x by dt square plus s into x is equal to 0, s by m into x is equal to 0. Thereby, omega I am able to find by means of omega is equal to s by m root. Okay. So this s by m I am finding with respect to g and delta by the relation m into g is equal to s into delta, right? So this is a very easy expression that you can recap very easily, right? Now after this, we are having the next variety, that is transverse vibrations. So transverse means axis is perpendicular to the longitudinal axis. Transverse vibrations. So this is just, you remember in MYS you are having a cantilever beam. So there you are having attached mass m, right? Now you pluck it. That means you give a moment for this. You give a moment for this and release it. Then how it moves? I think it is like this. Right? So it is oscillating like this.
Release method లేదు సార్.
రిలీజ్ మెథడ్ ఉంది. ఇప్పుడు ఏం లేదు, మీకు ఇంకా 10 minutes టైం ఉందని చెప్పి రిలీజ్ మెథడ్ ఇంకా చెప్పలేదు. రిలీజ్ మెథడ్ ఉంది.
ఓకే సార్.
డోంట్ వరీ. రిలీజ్ మెథడ్ చెప్తే ఏమవుతుందంటే ఇప్పుడు మళ్ళీ ప్రాబ్లం చెప్పడానికి టైం సరిపోదని రిలీజ్ మెథడ్ తర్వాత చెప్తాను. ఓకేనా? డోంట్ వరీ. ఓకే, రైట్. So here what will happen, whatever the moment, here in the transverse vibration we are taking some approximation. Okay, frankly speaking, if you take any cantilever beam and if you give the moment, the actual moment will be a curve, right? Actual moment will be a curve, but this is applied to the very narrow area. That's why we are taking it as straight line. Just like you remember the tuning fork. So how much distance it is moving, the amplitude is very small. When amplitude is very small, you can take the moment of the last mass attached to the beam. That can be taken as the path can be taken as straight line in violating with your radius of an arc, right? Now, if it is moving as a straight line, then the same thing, either in the energy method or in the equilibrium method, the same equation will come d square x by dt square plus s by m into x is equal to 0, right? So, in analogy to your thing, omega is equal to root s by m, right? This is equal to root z by delta. Then finally, we are getting that time period is equal to t is equal to 2 pi root delta by g. All these things will come as usual, but you may ask, longitudinal vibration and transverse vibration, if you are having the same time period, what's the difference between these two? Delta is the difference. This is the main thing, because the frequency is the same equation 4985.4985 by root delta. The delta is the variance, right? Now, some of you can answer this question. What is the value of the delta when a cantilever beam is there and you are giving some moment at the exterior position? Okay, I will give some values. This is, okay, I will give the cantilever beam. This is the point load, W, okay. This is L, and it is having the material with E, right? Then what what could be the delta value?
WLQ by 3EI, sir.
Oh, nice. So delta is equal to WL cube by 3EI. I is the moment of inertia, right? Okay. Now, by using these formulations, automatically you are able to calculate the longitudinal vibrations and transverse vibrations of any beam or any structure, right? Very, very easily. Now we shall take a very small problem. That is already in your textbook. Okay. Mm. Okay, I will show you here. Oh, not pasting well. Okay. Mhm. I control that. 1 second. I'm cutting one problem. What happened? Sharing is paused until you return to the shared window. Okay. What happened? Are you seeing the paint 3D?
No, sir.
Okay. Okay. Now, right. I think you are able to see some problem here. Are you looking the problem? Hey, students?
Visible, sir.
Yeah, yeah. Okay, nice. So, a cantilever of a shaft 50 mm diameter and 300 mm long has a disk of mass 100 kg, right? At free end. Whatever the diagram I have given earlier, the same thing. This is the shaft and this is the free end. So 50 mm diameter. So D is equal to 50 mm and L is equal to, this is L, this is the diameter D, and L is equal to 300 mm. Mass M is equal to 100 kg. Young's modulus is given 200 giganewton per meter square. Giga ante 10 power 9 Newton per meter square. Determine the frequency of longitudinal and transverse vibrations of the shaft. Right. So for longitudinal, the problem is very easy, but you need to write the formulation clearly. For longitudinal, transverse. For both, I need to find the delta. Suppose the delta longitudinal delta L. This will be WL by AE. For this transverse delta small t, this is equal to WL cube by 3EI. Okay. I think all the information is given very easily, right? Okay. I will increase the canvas. Okay. Right. Now I think everybody could find these parameters very easily, because in the longitudinal case, okay, brush is to be selected. Okay, right, black. So when mass is given, the weight will be 100 into 9.81 into L. The length is 300 mm, so 0.3 meters divided by area, pi by 4 into d square. D is 0.05 whole square into E, Young's modulus, 200 into 10 power 9. Right. So from this I will get delta of longitudinal in meters. Then I could find F is equal to point FL. So in the longitudinal vibration frequency, 0.4985 by root delta. So we can find very easily and write it as hedge, right? Now what about this transverse vibration? WLQ by 3EI. So W will be M into G, L cube, 0.3 whole cube divided by 3, 3 E, 200 into 10 power 9 into I. I is polar moment of inertia, not polar, okay. Moment of inertia of this particular shaft. This is pi by 64 d power 4. Oh, 1 minute. So the D is already given to you. So 50.05 whole power 4, right? So from this delta T, something meters will come. So frequency in the case of transverse vibration, 0.4985 divided by root delta T. Earlier it is delta L, now it is delta T. You will get some value, call it as hedge, right? So what is asked here? Determine the frequency of longitudinal and transverse vibrations of the shaft. Okay. So like this, you are able to find very easily. Okay. So sometimes there may be some extra loading. So just to remember the formulations already known to you, everybody, how to find the delta values in the case of the cantilever with the different types of loadings, right? So the main thing in this vibrations is to find your delta value. After finding the delta value, then frequency can be identified very easily, or if time period is asked, you can calculate the time period, you can calculate omega, whatever the parameter, right? So similar to this, you may have so many problems that are available in the textbooks, right? Okay, so sorry is calling. Okay. So any doubt? So in this portion, you will be given one question, right? And one more thing, actually the Rayleigh's method could also be discussed if the time is available. Okay. So Rayleigh's method means it relates to the maximum kinetic energy. It is also related to the energy only. It is also the energy, right? Earlier we are having just similar to the Bernoulli's principles, right? My God. It is also related to the d by dt of potential energy plus kinetic energy equal to 0. That is in the energy method. But in the Rayleigh's method, uh, the maximum kinetic energy in the main position is equal to maximum potential energy at the extreme position. That means you are moving like this. You are moving like this. Okay. So at the downmost point, this is your main position. So here I am having kinetic energy maximum. So moving to the left extreme. So here I am having maximum potential energy. So what is the maximum potential energy at this point? What is the kinetic energy at this point? Make these two are equal. Make these two are equal, right? So then, so how I am moving from the maximum kinetic energy point to the maximum potential energy point. So already we know everything about this simple harmonic motion, right? So for this simple harmonic motion, I need to take how the simple harmonic motion will be an example. I think in the kinematics of machinery, we discussed something, right? Okay. Otherwise, I will. Time is okay, no problem. I will open it. I will open the Paint 3D and I will share with you. Okay. New. Right. I will share Paint 3D. Right. Okay. So the canvas. First of all, my duty is to increase the canvas. After that, you can write so many things. Okay. I will take the brush. Rayleigh's method. So I am moving from. This is the main position of a simple pendulum or spring mass system, anything, right? Now I am moving left extreme to the right extreme, like this, right? Got the point. So this is the main position. This is extreme position, right? So here, uh, about your kinetic energy and the potential energy. At this point, I am having maximum potential energy. Here I am having maximum kinetic energy. Even though you are calling the terms are maximum or something, only PE will be there in the extreme position because it is coming back again at the extreme position. Here also the same thing. So only potential energy and only kinetic energy will be there, right? Okay. Now we need to derive these two are making equal. You need to make these two are equal, right? Now what is the equation for your displacement in the simple harmonic motion? Simple harmonic motion, you can see it. X is equal to x sine omega t. So x is capital X will be maximum displacement. అసలు ఇదంతా మనకి ఎక్కడి నుంచి వచ్చింది అంటే I will show you. Actually, I think I discussed in the case of the kinematics of machinery the angular momentum equations, right? Okay, no problem at all. So this is the radius, okay? So the body is an attached body So see this, I am attaching some ball and it is rotating like this. Okay. Now at one position it reached here. Agreed? So this is also R. Now it is subtending some angle theta here. Okay. Now the vertical moment, just you look after this ball moment. After some time it will be here. After some time it will be here. Sometime. Again return to the same position. Again moving along this circumference. Right. So it is rotating around this circumference. But the shade or the impression of your ball onto the vertical diagonal. This is the vertical, right? Now the image of this ball along this line, it is an example for simple harmonic motion. Got a point? So what is the image here? Point. Now what is the image here? A black point. After some time, here this point. After some time, this point. Now how it is oscillating? See the black arrows moving about the mean position. This is the mean. Okay. Now, how to trace the equation for this item? So, this is R, this is also R. Now, what is the position? This is, okay, I will erase the remaining things. I will keep only the important one. Now, you could see, suppose this is A, this is B, this is position is C, right? So, X is equal to AB, not AB, 1 minute. This is the position, initial position can be taken as O. What happened? Okay. O, this is C, this is B, this is A. So the displacement from the original position, it is going as small x, right? Now x is equal to AO minus AB. Agreed? Then your x will be equal to AO. AO is equal to R. Now your AB is equal to R cos theta. So R into 1 minus cos theta. Right? So like this, you are getting the x equation. Thereby, the simple format will be 1 minute. This is going to be some other equation. If you take the horizontal component, then it will become the sine, and you are getting the equation with respect to the sine omega t. So, because this is moving in a horizontal direction, the maximum displacement will be x. In the case of the rotation, it will be equal to radius small r. Okay. Actually, earlier it is the x sine theta. This sine theta may be theta is equal to omega t. When a body is rotating in an angular way, theta will be equal to omega t. So x is equal to x sine omega t. So velocity will be equal to dx by dt. So I can make x omega sine cos omega t. Right? Now I need to get maximum because I am asking maximum kinetic energy. So Vmax. So cos maximum ఎప్పుడు అవుతుంది 1 అవుతుంది. So at 0 degrees. So omega x at a time t is equal to 0. Because the cos is maximum 1 at 0. So omega t 0. Omega t 0 into omega 0, no chance. So t is equal to 0. So this is Vmax. Now your kinetic energy will be half m Vmax square. So this means m omega square x square by 2. So this will be kinetic energy, right? Now, what will become the potential energy? It is the same thing. Just remember earlier in the energy method, whatever you calculated earlier, the same thing will be potential energy. So the potential energy will be equal to mean force into displacement. So this will be 0 plus s into x by 2 into x. So this will be half s x square, right? Now you can make both of them to be equal. Yeah, 1 minute here. This can be capital X. Okay, right. So m omega square x square by 2 is equal to half s into x square. Now you can cancel 2 is cancel, 2 is cancel, x square, x square. Now omega square is equal to s by m. That means your omega will be equal to root s by m. Din pere g by delta. Once I am getting the omega, the remaining things will be automatic. What is automatic? Time is equal to 2 pi by omega, 2 pi root L by G. Okay, not L by G. Okay, 2 pi root delta by G. And frequency of oscillation, omega by 2 pi or 1 by T directly you can take it, 1 by 2 pi root G by delta 0.4985. The same thing we will repeat, hedge. So this is what the
సార్
portion
ఇందులో
of the
డెల్టా ఏం తీసుకుంటాం సార్?
ఏదమ్మా
డెల్టా ఇందులో ఏ ఫామ్ లో తీసుకుంటాం సార్?
యా డెల్టా మీకు ఇచ్చిన క్యాండిడేట్ ని బట్టి లాంగిట్యూడినల్ అనుకో రెండిటికి యాక్చువల్ గా ఎఫ్ ఈజ్ ఈక్వల్ టు 0.4985 బై డెల్టా ఏ. లాంగిట్యూడినల్ అయితే ఐఎమ్ రైటింగ్ డెల్టా ఈజ్ ఈక్వల్ టు డబ్ల్యూఎల్ బై ఏఈ, రైట్? ఇది క్యాంటిలివర్ మన ఎగ్జాంపుల్ తీసుకుంటాను. ఇన్ జనరల్ క్యాంటిలివర్ ఎందుకు తీసుకోవాలి సార్, సింపుల్ సపోర్టెడ్ తీసుకోకూడదా అని అడగచ్చు. Because we need to give some movement and you need to make it free to move. Simply supported lo free ga movement ఉండదు. There are degrees of freedom is very limited, right? So generally we are taking the cantilever and we are giving some plucking and this is oscillating like this, right? So longitudinal ఇస్తే delta WL by AE వేయండి. ఒకవేళ transverse, if it is given that the transverse vibrations for cantilever you take it as WL cube by 3EI, right? And automatically this is the delta small l, there's a small t. F is equal to whatever it might be 4985 by root delta. But in the examination, if it is given in the end examinations, how the frequency is coming, you don't write directly. Frequency means 1 by 2 pi to put 3 by delta. So substitute 9.81, substitute 2 into pi, then you write 0.4985 by root delta. Direct formula వేసేస్తానంటే మీకు అన్ని మార్కులు ఇవ్వరు ఎగ్జామ్లో, రైట్? Is it clear for all of you? So similar problems you can find in the textbooks, no problem. So the remaining portion, we are going to complete some of the portion. The other portions important one, natural frequency of the free vibrations, so that is okay. And there is another topic called effect of inertia of the constraint in longitudinal and transverse vibration. What is the effect of inertia? After that, we'll go to remaining portions. Natural frequency of the free tangential vibrations, right? And just now we discussed about the simply supported, right? So how is it is having the effect on simply supported beam or shaft? If it is the mechanics of solids, we will call it a simply supported beam. But here we are giving some word change, simply supported shaft. Okay. Okay. So remaining portion we'll discuss on Monday. If it is online or offline, I don't know exactly, right? So I'm going to stop the recording.